This is the third video in the module on entity routing. In the first two videos of the module, we talked about entity destination and outbound link selection. So these two videos provide a basic knowledge that can help you better understand the topics that we cover in the rest of this module. From this video on, we're going to talk about different types of routing logic in Simio. In this video, we're going to use selection weights to perform probabilistic routing, conditional routing, and we will also talk about compound probabilistic and conditional expressions for selection weights. In the fourth video of the module, we're going to use node lists to perform dynamic routing, where the destination node of our entities will be selected dynamically based on the current state of the system. Finally, in the fifth video of the module, we will learn routing with sequences or sequence tables where the entities in our model need to visit a predetermined sequence of nodes or objects in the model. So here's a flowchart of the specific topics that we cover in this module. In the first two videos of the module, we covered basic concepts related to entity routing. So we talked about basic and transfer nodes and their properties and how they can be used to specify a destination node for the entities or to select an outbound link for the entities to take. So in terms of entity destination, we have two cases. The first case is when the entity does not have a destination node set. In this case, in the first video, we covered free space movement, where we do not have a network of link objects. In the case where we have a network of paths or connectors, we talked about the case where there is only a single outbound link. For the case where we have multiple outbound links out of our transfer node, we learned how we can use the properties of the transfer node to specify a specific link for the entities to take. And we also talked about selection weights. In this video, we're going to focus more on this concept, and we will learn how we can use the selection weight property of our link objects to perform probabilistic and conditional routing. So the second general case that we talked about in the second video of the module was the case where the destination node of the entity is set. So in this case, we talked about how we can use a set node step or the entity destination type property to specify the destination node for our entities. So we talked about outbound link preference and outbound link rule and the different situations that can happen based on the choice of these two properties. We're going to talk about routing using node lists and dynamic routing in the fourth video of the module, which again is a case where the destination node is set. However, the destination node is selected dynamically as the simulation is running. In the fifth video of the module, we're going to talk about routing using sequence tables, where the entities need to visit a predetermined sequence of nodes. So again, we know what the destination node for the entities will be as entities move through our model. So we're going to talk about these different types of entity routing in the context of an example that is based on the operation of the airport security checkpoint. The airport security checkpoint has two main steps. The first one is a document check, where TSA checks your ticket and your ID, and then they will go through the advanced imaging machine, which they call AIT, that stands for Advanced Imaging Technology, which is basically an X-ray machine. Also note that there is another option that is called TSA PreCheck, which is a program that you can participate in if you register for it. And then if you're accepted, they will allow you to leave your shoes and jackets on, and also you don't have to take your laptop out of your backpack. So as you can see in this model, we assume that passengers arrive at a rate of 720 per hour, into this security checkpoint system, and 90% of the passengers are regular people that go through the regular screening equipment. And also note that we have this possibility of 10% of failing the screening process, which most of the times happen because people forget to take everything out of their pockets, or they just don't stand the right way when the machine is scanning. So they have to repeat the process and go through the machine again. And finally, we have 10% of the passengers that are eligible for pre-check. So let's go to Simio and start building this model. What I need is my source object and my 3 server objects. And finally, my sync object. I'm going to connect these up with paths. Let me switch to multi-placement mode. And I also have this reentrant flow back into the screening server. So now I have my servers and I have my paths set up. Let me put my model entity or default entity on the facility view, and I'm going to rename my objects. So I have passengers. So the first one is document check, doc check, and then we have AIT, and we have pre-check. So now I'm just going to hit run just to make sure that everything is connected and my entities flow in the system. So the next step I'm going to do is implement my probabilistic routing logic. So as you can see, I have 90% of my passengers that go from the first stage to the AIT server. So I'm going to have my selection weight for the path that goes from doccheck to AIT set to 0.9, and the alternative will be 0.1. And I also have a possibility of 10% of failing the screening process here. So on this path, I'm going to use a selection weight of 0.1, and the alternative is 0.9. Let me just make this note that it really doesn't matter what value you put in the selection weight. As long as the proportions are right, your routing logic will do what you want it to do. So right now I have 0.9 and 0.1 on these two paths. I can also have 90 and 10 or 9 and 1. Again, as long as the proportions are right, Simio will route the entities according to the proportions that you put in. So let me go ahead and put in my inter-arrival time. So I know my arrival rate is 720 per hour. So I'm just going to let Simio calculate my inter-arrival time. So I'm going to put in 1 over 720. And I'm going to set the units to hours. And also I have different units of capacity on my server. So I have 3 units of capacity, or 3 TSA officers that check the IDs and tickets. And I have 3 AIT equipment. So I'm going to change the capacity of my AIT to 3 also. And I will leave the capacity of the pre-check to 1. Also note that our focus is more on the implementation of different types of routing, and we're not going to really do any analysis with the models that we develop. And as you can see, we will leave most of the parameters of the model to their default values just to save some time. But of course, when you're doing this model as part of a project, you will need to verify your model as you add more features to it. So now, if you would like to verify this model that we currently have, what you need to do is develop a static model, a queuing model of this system, and then adjust the parameters of your simulation model so that it corresponds to your queuing assumptions. And then you will need to run an experiment, run your model for a long time, add warm-up period, and replicate your model in order to be able to compare the results of your simulation model with your queuing model to gain confidence that your probabilistic routing is implemented correctly. But we're not going to do these steps for the models that we develop. So the first model that implements only probabilistic routing was easy, and we had seen many examples of it before. In the second model, we're going to add a new component to our model, which is a pat-down station. And the way the pat-down station works is that if an entity or a passenger fails the screening, the X-ray twice, the passenger is still checked or screened using the X-ray machine for the third time, but regardless of what the outcome of that screening is, the passenger will also need to go through pat-down. So let's go to Simio and see how we can implement this logic. The first thing I need is my server object, which is my pat-down station. Let me move my sync object a little bit. So I'm going to connect AIT to my new server and server it to sync. And also I'm going to rename it to pat-down and change its capacity to 2. And as you can see, I have this condition that sends entities to the pat-down station if the entity has failed the screening 2 times. So when you think about it, what we really need is a mechanism to count the number of times that each entity goes through AIT. Basically what we need is a model entity state. So I'm going to go to model entity, definitions, states, and I'm going to define a new integer state, and I'm going to call it numScreened. So now when an entity is created, it has this attribute associated with it that initially has a value of 0 stored in it. So now I go to the model, and the next thing that I need to implement is the logic to increment the value of the numScreened for each entity when the entity goes through the AIT. So I'm going to do this by incrementing the value when the entity enters the AIT station. And I'm going to use a state assignment. Also recall that you can also use add-on processes to do state assignments. So I'm going to change or increment the value of my model entity numScreened. I'm going to increment it by 1 whenever the entity enters the AIT server. So when the entity enters the AIT from doccheck, it becomes 1. So remember, the default value was 0. And then if it fails for the first time, it becomes 2. And the entity fails the screening for the second time, the value becomes 3. So what I need to tell Simio to do is send the entity if the value of model entity.numScreened is equal to 3. So I'm going to use my selection weight to implement this condition. And the expression I need is model entity dot numScreened equal to 3. And I also need to make modifications to the selection weights for my other two paths. So what I'm going to do is multiply 0.9 by model entity dot numScreened less than 3. And I'll explain shortly why we do this. And I'm going to do the same thing for my other path that goes back to AIT. So let's just paste here. So now let's see what happens when an entity is about to be transferred out of the output node of AIT. So if model entity numScreened value is less than 3, that means the entity is processed on AIT either 1 or 2 times, then this expression right here becomes 1. So my link weight or selection weight essentially becomes 0.1. So the entity will be routed back to the AIT with a probability of 0.1. Similarly, if the entity is processed less than 3 times on AIT, then this expression will become 1. So the entity will be routed to the sink with a probability of 0.9. Otherwise, if the entity has already failed the AIT screening process twice and it's been processed on AIT 3 times, then this expression will become true and the entity will be routed to pat down. So in order to verify that this logic actually works, I'm going to increase the size of my passenger a little bit. And what I specifically like to do here is change the color of or the symbol of my passenger based on the number of times that model entities are processed on AIT. So what I'm going to need is 2 additional symbols. So for my second symbol, I'm going to use a light red color. I'm going to apply it to my passenger model entity instance. And then I'm going to select my third symbol, and I'm going to use dark red to represent the passengers that need to go to pat down. Now, as you can see, I have my symbols defined. So those that do not fail the AIT have the default green color. Those that fail once have this color, and then those that fail twice has this red color. The last thing I need to do is to implement the logic to change the model entity.picture state. So I'm going to do this on the path, and I would like to use a state assignment, and the state that I would like to change is model entity.picture right here, and I would like to increment its value by 1. So now when the entity fails for the first time, model entity.picture for that entity becomes 1. So I will be using the second color in my symbol list, and when it fails for the second time, this model entity.picture state becomes 2, and I will be using the third symbol in my symbol list. So now let's run the model and see what happens. So as you can see, if they fail for the first time, they're represented with a light red color, and those that fail more than once, hopefully we'll see one of them soon, will be changed to dark red color and will be routed to the pat down station. So let me increase my run speed a little bit to see if we see an entity that fails twice. And as you can see, at some points we'll see some entities that have a dark red color that go through the pat down station. So in this video, we learned how we can use the selection weight property of the link objects for probabilistic and conditional routing. So when we have probabilistic routing, we simply assign values, numeric values, to our selection weight properties, and Simia will route entities probabilistically based on the weights that we specify for the outbound links. We also saw that for conditional routing, we can have expressions for our selection weight property. So for instance, for the path that goes to the path down station, we have this condition and we specify our condition in our selection weight property. We also saw compound expressions where we have a numeric part that is the probabilistic part and a condition that in this case is based on a model entity state variable. So in the rest of the module, we're going to talk about dynamic routing using node lists in video 4, and finally routing using sequence tables in the 5th video.